Our competency is the learner is able to solve problems involving sequences. Objective: after this video, the learners are expected to recognize arithmetic or geometric sequence in word problems, apply concepts of arithmetic and geometric sequences and series in word problems, solve word problems involving sequences. Let us have a recall. Arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. An arithmetic series is the sum of the terms in an arithmetic sequence. The nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub 1 represents the first term, n is the number of terms, d represents the common difference, and a sub n represents the nth term. The sum, which is s sub n, of the terms of the arithmetic sequence is given by s sub n is equal to n times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Geometric sequence is a sequence in which each succeeding term is found by multiplying the same number called the common ratio to the previous number. A geometric series is the sum of the terms in a geometric sequence. The general formula for finding the nth term of a geometric sequence defined by a sub n is equal to a sub 1 times r to the power of n minus 1, where r denotes the common ratio of the sequence. The sum s sub n of the terms of the geometric sequence is given by s sub n is equal to a sub 1 times the quantity of 1 minus r to the n all over 1 minus r, where r is not equal to 1. Let us have example number 1. What is the difference between the 7th term and the 13th terms of 2, 6, 10, 14, and so on? In other words, 13th term minus the 7th term. We will have the solution. The sequence given is 2, 6, 10, 14, and so on. If we observe the pattern of this sequence, we see that this is an arithmetic sequence, since we can keep adding 4 to the preceding terms to obtain the next. We have the known quantities, which are the first term, or the a sub 1, which is 2, and then the common difference, which is 4. We have unknown quantities. We have the 7th term, 13th term, and then 13th term minus the 7th term. For solving the unknown quantities, we have the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times 2. Let us solve first the 7th term. We have a sub 7 is equal to a sub 1 plus the quantity of 7 minus 1 times d. Since our first term is 2 and the common difference is 4, so we have 6 times 4 is 24 plus 2 is equal to 26. Our 7th term is 26. For the 13th term, we have a sub 1 plus the quantity of 13 minus 1 times d. Our first term is 2 and our common difference is 4. So 14 times 12 is 48 plus 2 is equal to 50. In other words, 13th term minus the 7th term, which are 50 and 26, so the difference is 24. Example number 2. Find the sum of the odd integers from 3 to 99. So we have the solution. We can write the sequence of odd integers from 3 to 99 as 3, 5, 7, and so on, and 7, 99. If we observe the pattern of the sequence, we see that this is an arithmetic sequence. Since we can keep adding 2 to the preceding terms to obtain the next. So we have our known quantities, which are the first term, which is 3, the nth term, which is 99, and then the common difference, which is 2. Our unknown quantities are the n and s sub n. So for solving for the unknown quantities, we have to solve for n. So we're going to use the formula in finding the n term of an arithmetic sequence. So we have here a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So by substitution, our n term is 99, our first term is 3, and our common difference is 2. 2n is equal to 98. 98 divided by 2 is equal to 49. So we're going now to substitute the n in our formula, which is the s of n is equal to n over 2 times the quantity of a sub 1 plus a sub n. So we have 49 over 2 times the quantity of 3 plus 99. 3 plus 99 is equal to 102. 49 divided by 2 is 24.5. So we have 2,499. For our example number 3, as early as grade 3, Kent Rollins was taught by his parents to save money. He has a piggy bank with an initial amount of 500 pesos. He starts to deposit money every month in the following pattern for a period of 2 years. So we have 10, 15, 20, 25, and so on. How much will be the total amount of money he has after 2 years? So for our solution, this is our given sequence: 10, 15, 20, 25, and so on. This is an arithmetic sequence since we can keep adding 5 to the preceding term to obtain the next. And our known quantities are, the first term is 2, common difference is 5, and our n is 24, since 2 years is equivalent to 24 months. Our unknown quantities are S sub 24 and the total amount of money Kent has after 2 years. So for solving the unknown quantities, the total amount will be the initial money plus the sum of all the monthly savings. So 500 plus sum of all the sequence, which is S sub 24. So we have S sub 24 is equal to n over 2 times the quantity of 2a sub 1 plus n minus 1 times t. So we have here, through substitution, we obtain this one. 24 divided by 2 is 12. 2 times 10 is 20. 24 minus 1 is 23. Times 5, which is 115. Plus 20 times 12, which is equal to 1,620. The sum of all his money saved for 2 years is 1,620. Therefore, his total money in 2 years is 500 plus 1,620 is 2,120. We have activity 1, which is called All for You. Read and analyze and solve the problem below. Show all solutions. Each of the correct answers correspond to a letter on the right, which answers the puzzle at the bottom. A ball falls from the top of a tower. After 1 second, it drops 5 meters below the top of the tower and increases by 9.8 meters for every subsequent second. Question: is the sequence arithmetic or geometric? From 2 to 7, write the first 6 terms of this sequence. How many meters did the ball drop on the 10th second? What is the total distance the ball traveled after falling for 10 seconds? If the ball hits the ground on the 13th second, how high is the tower? So this will be our questions. These are our choices. We're going to go back with our problem. So our given here is that after 1 second, the ball drops 5 meters below and increases by 9 meters for every subsequent second. So is it arithmetic or geometric? So we are going to write the first 6 terms of this sequence. So we know that the first term is 5. So since after 1 second, it drops 5 meters below and increases by 9.8 meters for every subsequent second. So after 5 meters, what is the next? So you are going to write 6 terms of this sequence. 5 is the first term, which is, I will give it to you. Second, third, fourth, fifth, and sixth. Then use calculator to make it sure of your answers. For question number 8, how many meters did the ball drop on the 10th second? In other words, you're going to find the 10th term. And for number 9, what is the total distance the ball traveled after falling for 10 seconds? Since we're talking about total, we're looking here for the S sub 10. And lastly, if the ball hits the ground on the 13th second, how high is the tower? So each answer corresponds to a letter. Okay. Let's try to check your answer. Number 1, it is an arithmetic sequence. You're right, very good. And this is our sequence. The first term is 5, which is I. Number 3, our second term is 14.8, since 5 plus 9.8 is 14.8. The third term is 14.8 plus 9.8 is 24.6, which is R. The fourth term is 24.6 plus 19.8 is equal to 34.4. Next, 34.4 plus 9.8 is equal to 44.2. Is our fifth term. And for our sixth term, it's 44.2 plus 9.8 is equal to 54. This is U. Very good. You got it all right here. For number 8, we have our 10th term. So our first term is 5 plus 10 minus 1, since we're looking for the 10th term, times our common difference, which is 9.8. So that will be 10 plus 10 minus 1 is 9 times 9.8 plus 5 is equal to 93.2, which is letter J. Very good. And for our number 9, which is the S sub 10, we will be having here 10 times the quantity of 2 times the first term, which is 5, plus the quantity of 10 minus 1 times the common difference, 9.8. And our answer for this is 982, which is letter L. Very good. And lastly, we have the 13th term, which is 5 plus 13 minus 1 times the quantity of 9.8. 12 times 9.8 plus 5 is equal to 122.6, which is letter H. Alright, very good. So we're going to proceed to our puzzle. What tower was the ball dropped? So we have here our boxes. These are our answers a while ago. So we are going to fill in the box. So we have here 3. This will be letter B. 7 is U. 4 is R. 8 is J. 5 is K. And 10 is H. 1 is A. 9 is L. 2 is I. 6 is F. 1 is A. So the tower was Burj Khalifa. Alright. We'll proceed now to activity 2, which is finding. Solve the following problem. Show all your solutions. For this activity, you are going to check this one with your teacher. Problem number 1. If the sum of the first 5 terms of a geometric series is 1023, with its first term equal to 3, then what is the common ratio of this sequence? Again, if the sum of the first 5 terms of a geometric series is 1023, with its first term equal to 3, then what is the common ratio of this sequence? Question number 2. Mark Roland saves as follows: 60 pesos on the first week, 100 pesos on the second week, 140 on the third week, and so on, for 1 year, or a total of 52 weeks. Can you identify the amount of his 50-second deposit? Okay. So those are our 2 problems for activity 2. So we have here things to remember. In solving problems involving sequences and series, first, we are going to look for the given sequence. Number 2, if not given, determine whether the pattern resembles an arithmetic sequence or a geometric sequence, giving appropriate justification. Number 3, determine the known quantities and the quantities to be solved. And number 4, the pattern is arithmetic in nature. Use the concepts and techniques taught in module number 2. Finding common difference, finding the nth term of the sequence, sum, and etc. And lastly, if the pattern is geometric in nature, use the concepts and techniques taught in module number 4. Finding common ratio, finding the nth term of the sequence, sum, and etc. Okay, good luck with your activity. I hope you learned something from this video. Thank you so much. I would like to give credit to Elder Trout Master 175 from Caloocan City. Of course, hero.com for the beautiful leaves one. Thank you so much for watching. Goodbye, everyone.